studied quantum physics before, and let's see whether I'm able to make you an expert in quantum physics. If I'm able to do that, then this will be the target. This will be the goal. This will be the success of these 2 hours. All right, should we do that?
Yeah.
Okay. Before that, let me tell you something. There's a technique, a study technique that I'm creating, and with that techniques, apparently I tested on a few of them, and it's not only quantum physics. Is almost anything. It's also not only physics. It could be history, it could be chemistry, it could be biology, and that helps whoever who follow these steps. This I call it BrainDrawer method, is able to understand that particular chapter very, very well. So let's see. Before I go into this quantum physics, let me tell you some principle or some techniques that I use to build this BrainDrawer study method. So with that, then you'll be able to understand why, because in the BrainDrawer method, there are 8 steps. So with that, you'll be able to understand why step 1 is being done that way, step 2, step 3, step 4. Then you'll be able to appreciate it better, right? So let me do a screen sharing first. Okay, let's close this screen share. All right. Do you see my screen?
Yeah.
All right. Okay. There are 4 main techniques or 4 main principles that I built this study method. Let's start with number 1. Number 1 is, do you know what is the difference between a smarter student and a normal student? If I want to give you a chance to answer, how would you answer these questions?
A smarter student knows more facts.
Okay, that's good. That is exactly the point number 1. All right. As far as I define student A, let's name them student A and student B. Let's name Easy as student B right now. And how do we make Easy to become student A? Student A is the sharper, is the better version of student B. That means a better version of Easy right now, today. And there are 3 main trainable skills. Number 1 is the one that you mentioned just now. She has a bigger knowledge base. She knows more than Easy B, right? Easy A knows more than Easy B. Number 2 is Easy A is having the recall speed faster than Easy B. What do I mean by that? You are able to retrieve the information inside your knowledge base, which is inside your brain, faster compared to the B version of yourself. So whether you take it out to present it as a presentation, whether you take it out to present it as a normal conversation, normal intelligent intellectual conversation with your friends, with your tutor, with your teachers, or anything else, right? So the speed of recall. Number 3 is when you identify any new information around you, whether it's through watching a YouTube, whether it's through going on a session like this with me, anything, right? Talking to people, observing your environment, or going for a visit in another countries. So those are new informations or new experience or new understanding that you identify, and you're able to store it back into your knowledge base. And it's not just store it in any slot. Store it systematically and in an organized way. So that is to differentiate between easy A and easy B. Student A, which is smarter, compared to student B, which is a normal student, right? So that is the first principle or first thing that you need to know, because later we will be using this, and in the steps, some of the steps I'll be telling you that we are focusing on for example, trainable skill number 2, fast recall. Trainable skill number 3, systematically store your information. With that, marker, then and also with this explanation that I explained to you just now, so it's easy for you to relate why this step is being done that way, and you'll be appreciating this better, and you'll be learning this the notes that is given much faster, right? So let's move to number 2. A while ago, I think I played this memory game with you before. Do you still remember the memory game that is number 1 until number 10? And
Yeah.
right. So I will not go through this game with you again, but the key information that you need to know is this formula. Information plus emotions equivalent to long-term memory. Because our brain, I mean human brain, doesn't work in plain text. We don't work with plain text so well. We work with emotions better. When emotions is embedded into this information, the retention capability increased by multiple of time, right? I think it has proven to you at that time your memory increased by, at least for the game example, by 2 or 3 times, right? You still remember the game?
Yeah, I do. I don't remember the list though.
Yeah, you don't remember the list. No, don't worry. I'm not here to test you on that. But the key message in the game, right? Now, point number 3 is we are trying to reduce the chances of procrastinations, right? When you are being assigned to a task that is so boring and assigned to a task that is so repetitive, chances of you continuing doing that for a long period of time is much lower compared if the task is shorter, right? That is just normal logic, 1 plus 1 equivalent to 2, right? So how this BrainDrawer method is able to reduce this procrastination chances, right? I'll give you one example. How do I study? Before I discovered this BrainDrawer method, how do I study? When I was secondary school, or even recently when I study for my second master, I take out a book, and let's say that book is having 10 chapters. Let's pick out one of the chapters. Let's take the easiest chapter, chapter 1. I'll read the notes in the pages, right? I'll read all of them for the chapter 1. Let's say chapter 1 is containing 50 pages. So I'll be reading that 50 pages. Then at the same time, I'll be jotting down my notes. And those notes is to write down the keywords or the key information related to the chapter 1. So once I finish chapter 1, I will have maybe 1, 2, or 3 pages of the notes. What is the reason for the notes to be there? One is for me to recall faster. I do not need to read the entire 50 pages of that chapter 1 again, because that would take time compared to reading three pages. But what's the disadvantage over here? The disadvantage is you might not capture 100% of the content or the notes that is related to these 50 pages. So how do you know that it is not 100%? You will never know. If you know that it is 100%, you will have already filled up that gap, right? Is that the way that you study?
Yeah.
Right. So how do you fill up that gap? There are 2 types of students. The more laid-back student, they will wait until they go to the final exam. Then only they discover that, okay, out of 20 questions, there are 10 questions that they have no idea what is the answer, right? Reason is because the notes that they have been studying, the notes that I've jotted down and I've been studying, is not 100%, it's only 50%. So they are 50% of the information is not there. That's the reason why I'm not able to understand the questions of that 50% of the exam questions, right? There are another type of students, maybe student like yourself, which is more hardworking. So rather than waiting for the exam to discover your notes is not 100%, you start to do more practice and do more passive questions, and to check whether there are any question or any understanding or any concept that is new to you that is not written in that note, that 3 pages note that you just jot down, right? Then if there is, then you you definitely add in the new notes, whether with another marker pen or with another paper to make sure that you are covering 100% of the entire chapter 1, which is the 50 pages, right? So you have to do this a few times. And how all this process that I told you just now, from day one when you flip the first page and you read the 50 pages, then you do the notes, then you do past year questions, then you read again, then you add in the missing notes again to make sure that this note is near to 100%, so that is able to get you exam ready, to prepare you for the exam. How long do you take from that first moment until you are confident that your notes is reflecting 100% of the content? What do you think?
Like a week?
Yes, like a week, 2 weeks, 3 weeks, depending on how difficult is that chapter. If it is a chapter that is year 7, I'm sure easy, you will be able to do it easily, right? I think maybe
Yeah,
that's why they name it easy, because you can do things easily.
maybe.
All right. Okay, for chapter like quantum physics, maybe it will take 3 weeks rather than 1 week, because quantum physics, the name itself is hard to understand what is the content of that chapter, right? So this BrainDrawer method is integrating the AI, artificial intelligence, to make that process, that 3 weeks process, down to 2 to 3 hours. Right. Going back to the first message I told you related to the point number 3, the solution to reduce the chances of procrastination is very simple. Reduce the workload, reduce the time that is needed to do that particular task. So this is what we are trying to do here, to reduce the 3 weeks worth of work to 2 hours, right? So let's go to point number 4. Flying brain problem. What is this? Okay. I think everyone encountered this problem before, including me. And in fact, I did it a lot of time. I'll tell you what is the problem. You open the book, you try to understand the first page, and you read the first few sentences. Then your eyes move to the middle part of the page. Then it continues to the end. And before you flip to the second page, you are asking yourself, what did I read? Did I fully understand this page, or did I not fully understand? But during that time, from the first few sentences that you were focusing, then you lose your focus. Your brain has been distracted and has been pulled in to think of other things, whether my extra activities or school activities on Sunday or on Friday and Saturday is volleyball or is ping pong or swimming, whether I've completed my homework, whether I've done my laundry, whether I've planned for my vacation trip. By the time your mind wanders throughout entire world, and when you come back, and the next thing you know, your eyes is already reading on the last few sentences, and you are about to flip to the second page. Have you ever encountered this problem before?
Yeah.
Yes, a lot of time, right? Even me. So what
Yeah.
is this? Yes, what is the impact of this problem? The impact of this problem is you think that you read 200 hours, but in fact you only read maybe 100 hours, 50%, if you are good. Most of the people are only 10%, right? So the 200 hours that you spend so hard reading that particular materials to prepare you for an exam or prepare you for something else. In fact, the quality time that you spend is definitely less than 200 hours, and maybe it's only 20 hours, 10% of it. So in this BrainDrawer method, also, we are trying to address this flying brain problem. How are we going to address this? We are going to pull back our attentions, intentionally make it to be at this moment. Your brain needs to be with you in this moment, and it will not be wandering around. So there's a technique to do that. So that is the overall techniques that we use in BrainDrawer to be able to help you to understand, for this case, quantum physics in less than 2 hours. Right? I did it with my nephew. He did it in 1.5 hours. But because I've been doing this repetitively with him from chapter 1 until chapter 7, he is taking the SPM. SPM is like a final big exam before A level. And there is 7 chapters in Form 5. Form 5, I think, is a year equivalent to year 11 in your case. And we did it the entire year of the chapter 1 until chapter 7 in 3 days, because every chapter is less than 2 hours. So you can do the maths. 3 days is more than enough to cover 7 chapters. Right. So let's jump into the BrainDrawer, the quantum physics. Right. So now you understand these 4 techniques, 4 principles. Let's see whether how we can apply this in this quantum physics. Are you ready?
Yeah.
Yes, yes. Okay. Am I talking too slow or too fast or not clear? So far, everything
No,
is
it's
okay
fine.
or
Yeah.
okay? So you are following, right?
Yeah.
Okay. What time are we going to start? Let's write it down. We are starting now. Start at 7:18. Right. You know almost nothing about quantum physics. So that is the start. And see how far we can go. Are you a physics student?
I do physics, but it's like much, much simpler than this.
Much simpler. Right. No problem. Okay. Let's start. This is taken from Form 5, which is equivalent to, I think, year 11, if I'm not wrong. And that particular year we call SPM. SPM is a Malay term. So yeah, and that exam is a final exam. It's a big final exam for all the Malaysian students who is now maybe 16 or 17 years old. Your mom, myself, all the uncle, aunties that you met in the Malaysian, they took this exam maybe 30 years ago. So there are 7 chapters. We took the most advanced chapter, which is quantum physics. Right, as you can see, it is something related to Einstein. Einstein is the top scientist that we all know about. And okay, let's jump into this. The first steps, they are, as you see over here, there are 8 steps. So once we completed the 8 steps, then we will do a MCQ generated by AI. Okay, we will be worrying about that later. So let's start with step number 1. Excuse me. Create drawers, right? As the name itself is called BrainDrawer. So I'm creating drawer that can store inside your brain. This is not done yet. Let's remove the label done. For this particular chapter, quantum physics, there are 3 drawers I want to create for you. The first drawer is quantum theory of light. Excuse me. Second drawer is photoelectric effect. Third drawer is Einstein photoelectric theory. Now, the text, the word itself is quite advanced if you are not if you never learned quantum physics before. Even for me, when I started reading this a few days back, it is also quite advanced for me. I don't know what is it about. So to make yourself easier to remember this, what do? I create a short story. Right, let me just open my notes. Just give me a few seconds. Right. Step 1, we create a short story. A short story that is good for your memory to remember, right? So here's the simple connection of the story. Imagine Albert Einstein, the top scientist, walks into his room and switches on a light bulb. Einstein, so what do you see here? You see Einstein, you see the light switch, and then you see the light bulb, right? So they are the three key things that is important in this very short story. Einstein walks into his room, switches on a light bulb. Are you following me?
Yeah.
Right. So Einstein represents the third drawer. The third drawer. Switching on the bulb means there is no light. So it represents the second drawer, photoelectric effect. The bulb glowing, the bulb is turned on, meaning the light. Right. So now it's easier for you to associate the story with the three drawers. On a quick image, you see Einstein, you see electricity, you see light. Right. Second technique to make sure that these three drawers, at least the name of it, at least the Einstein, the electricity, the photoelectric, and also the quantum theory of light is sticking into your brain. So let's do sticker technique for visualization. Now let's strengthen this with the sticker method. Imagine three drawers in front of you, left, middle, and right. The first drawer on the left, we call it quantum theory of light. Now, stick a glowing light bulb sticker on the first drawer, right? Can you do that?
Yeah.
Right. That is your reminder of light. And that represents which drawer?
Quantum theory of light.
The first drawer. Okay.
Yeah.
All right. Number two, the second drawer, photoelectric effect. For electricity, we use the yellow thunderbolt sign, like it's a warning of danger, and instantly makes you think of electricity. Right. I think you have seen this type of sign before. Is like,
Yeah.
if you are touching it, then you'll be electrocuted. So stick it on the second drawer. Can you stick it now? Done?
Yeah.
Okay. The third drawer,
Yeah.
Einstein photoelectric theory. Right. For Einstein, picture a man with messy hair and with a big nose. At least that is what I can remember. Who is Einstein? So Albert Einstein itself. Stick this sticker face, on the third drawer. Can you do that now?
Yeah.
Right. So your three drawers are now the light bulb, quantum theory of light, the thunderbolt, photoelectric effect, the Einstein phase, Einstein photoelectric theory. That's it. Step one plus. Step one completed. We've built the drawers. In the next step, we will go to read keynotes. Let's label it done. Give me 10 seconds. I'll just get my water, else I'll be coughing throughout this session. Okay, I'm back. Now let's continue. Are you ready?
Yeah.
Okay. Read keynotes. So I prepare a keynote. Let me pull it out. Right. Can you see this keynote? Can you read it well?
Um, yeah.
Is it is it too small? No,
No, it's fine.
it's fine. Okay, let's take 3 to 5 minutes or 10 minutes for this case. I think there's quite a lot here to read these notes. But before that, if you realize it is being structured very systematically, you have the first drawer over here, quantum theory of light. You have the second drawer, the thunderbolt, photoelectric effect. You have Einstein, the photoelectric theory, right? And under each drawer, you have some notes, right? You have some notes. I think for this case, because you are first time going through this session, I'll read it together with you. And how do we read this? It is just by reading it, and don't worry too much about fully understanding everything. Our goal is just to collect the keywords and then place them into the right drawer, right? Collect the keywords and place them into the right drawer. Remember this. Let me pull this out again for you to remember. Okay. Remember this. Store systematically. What does it mean? When you identify new information, you need to know where to store it, right? All these notes for now is new information for you, I'm sure, because you never studied quantum physics before. So now I want
Yeah.
you to have this intention, the intention of storing, picking this new information out and storing it into the right drawers. So you have 3 drawers right in front of you. You can open the door of the drawer and put it inside, right? So how do we do that? Let's follow it with me for the first time. Now, all right. Drawer number 1, the quantum theory of light. Black body radiation. Absorb all magnetic radiation fall on it. Temperature and emission, cold object, low frequency. Hot object, high frequency. Now, as a first test, very simple test. Do you have any idea? Does it make any sense when you read these few words?
Yeah.
All right. So it makes some sense, but it is not fully making sense, I'm sure. All right. So don't worry about fully understanding this. And now what we need is the keywords. Like I say, we are just here to collect the keywords. And then what do? You place them into the right drawer. Now, the keyword is usually the keywords that is easy for you to remember. Something stick to your mind. Black body, right? Black body sounds interesting. Electromagnetic radiation is very abstract to understand. Temperature, emission, okay, it's too common. Frequency, low, high, also is quite common. Black body radiation, I think, is the good candidates for you to imagine, right? So imagine there's a black body, and pick that black body up, put it into your first drawer, and your first drawer is called quantum theory of light, and that is having a sticker of the light bulb, right? So now when you look into your first drawer, before the black body, it is totally empty. Now you have one item there, a black body inside. Are you following me?
Yeah.
Okay. So let's go to the next one. Let's read it quickly. Classic theory flaw. Predicted unlimited energy at high frequencies, but experiments show that it is not true. And they call it ultraviolet catastrophe. Makes sense a little bit, but not fully making sense yet. Right. So let's
Yeah.
pick, yes, let's pick something that is easy for you to remember and to store it inside your first drawer. Let's take ultraviolet. Right, ultraviolet is like a purple blue type of a thing, and there's a device that is having this ultra UV light. Pick it up, place it inside that drawer. Okay, the drawer that is having which sticker? The light bulb sticker, first drawer, quantum theory of light, right? Throughout these few steps, especially the few first initial steps, I will be very intentionally repeating what is the name of the drawer, what is the sticker of the drawer. I know at times it sounds irritating, but just bear with me because this is very important. I need to make sure that the drawers really, really, really stick into your mind by doing this repetitive reminder. And because it is very important for you to have that before you move to the following steps, 2, 3, 4, and following step. Even during that following step, I will also continue to repetitively reinforcing that if you understand or you can label which drawer is drawer 1, drawer 2, drawer 3. All right. So don't be irritated, but just be open-minded for now. For this 2 hours, bear with me. Just follow the flow. Can we do that?
Yeah.
Okay.
Yeah.
Number 3, you have scientists. You have this list of scientists. Some of the scientists, you know them. Some of the scientists, you never heard of them. So let's read this quickly. Isaac Newton, Thomas Young, John Thomson, Max Planck, Albert Einstein, Niels Broglie. Don't worry about remembering them for now. Just know that there is a bunch of very important top scientists and invite them into your drawers. So now your drawer is not as small as just putting your items. Your drawer can actually invite a lot of people to stay inside the drawer. Okay. So now you have the scientists. Next, quantum energy. Quantum energy is a discrete energy packet and not continuous energy. Photon are light energy transfer in quantum energy. This formula, H equivalent to Planck's constant. Line spectrum produced by an excited atom in a series of colored lines with unique wavelength and frequencies. Okay, now it's getting harder and harder. Do you get that feel? Do you get the sense also?
Yeah.
Right. So still don't worry. The key for now, for step 2, is not to understand everything, but to collect keywords. To collect keywords and to do these steps. To do this step, I have to bring this, and better to bring this next to it. Wait, to do this step, where is it? I have so many notes here. Yeah. Let me put it next to it. And it's easier to refer. To do this step, store systematically. Identify, store systematically. Right? So how do you, but you have to take a keyword. You can take quantum, but quantum, I think for now, it doesn't make any sense. Planck also doesn't make any sense. Line spectrum, it's too vague. What I do is I take a photon. Do you know the Malaysian national car, Proton?
Oh, yeah.
Yes. So drive that car into your drawer. Now your drawers become bigger and bigger. It's not just the conventional, typical drawer that you imagine just now. Okay, drive that car into your drawer. And there's a proton car inside with a bunch of scientists, with a UV light device, and with a black body there, a mystery black body. So next, wave particle duality, right? Wave particle duality exhibit the lights exhibit wave properties, diffractions, interference, and particle properties, momentum, kinetic energy, and collide with each other. And there's a formula, don't worry about that yet. Large mass, equivalent to or transmit shorter wavelength. The Broglie hypothesis, light particles such as electrons could exhibit wave characteristics. Totally doesn't make sense. Does it make sense for you? If it does, then you are Einstein. Doesn't make sense, right?
Yeah, it does. No.
It does or it does not.
No.
Okay. Why am I keep asking you questions? Because I want you to be engaged, right?
Yeah.
Also, it's part of the eliminating this it's not flying brain anymore. I think it's flying body problems, because your body will be doing other things, and maybe going, because I can't see you, right? So I need to make sure that you are there, because our objective is to have you, end of the day, answer 10 MCQ and see how many you can answer correctly with a start of 0 quantum physics knowledge, right? So can you help me to help you to achieve a good understanding? That's the objective, right?
Yeah.
There's the same
Yeah.
target for me and you, right? You're not here because your mom forced you to sit in front of the screen early in the morning. Am I right?
Yeah.
Okay. If it is, just pretend that it is not, and take that out and put in another goal that you, Lizzie, you spend this another maybe 1.5 hours. It's just 1.5 hours. Bear with me. And you will be able to understand quantum physics like Einstein. Okay?
Okay.
Okay, you have that 1.5 hours that you can focus
Yeah.
with me. Okay, I need that commitment. That's why. All right. Of course, I know that you're gonna say yeah, but I need that real commitment from your heart, right? Okay, let's do
Okay.
that. If you haven't done that, let's do that. Let's refresh your commitment. I want that. To be with you for 1.5 hours, just 1.5 hours. After that, I'll leave it to you to do whatever you want. All right. So now, back to the drawers. We have done quite some heavy keynotes that we discover, and we put it into the first drawer. And what's the name of the first drawer?
Light bulb.
Lizzie?
Oh, the name
Right?
or the sticker?
Yes, the sticker is light bulb. That's correct. Excellent. The name?
Quantum theory of light.
Excellent. Okay, so now, what is inside that drawer? Do you see my keynotes?
Yeah. It's
Yes.
the black body. Then you have the UV stick. The
Yep.
proton. The
Mm.
we didn't do the last one, but
Right. What do you have? You have a bunch of
the
scientists that you
proton.
invite them.
Oh yeah, the bunch of scientists. And
Right.
then
You can actually
proton.
refer to these keynotes. Don't worry. Right. So number 3 is the
Okay.
bunch of scientists. Then number 4 is the proton car. And number 5 is the wave particle duality. We haven't associate this wave particle duality to something that is easy for you to remember, to put it inside the drawer. I will use it as a coin with 2 sides. One side of the coin is having the picture of wave from the ocean, the wave. And the other side is around particles like balls, right? So the coins
Okay.
is having 2-sided, wave and particles. Particles is equivalent to balls, right? So you have 5 things inside your first drawer. So can you help me to close the first drawer door and then open the second door for the second drawer? Tell me when you're ready.
I'm ready.
All right. So the second drawer, the sticker that is in front of the door is a thunderbolt.
Lightning bolt.
Right, lightning bolt. Yes, let's use lightning bolt. And what is the name of the second drawer? The label.
Photoelectric effect.
All right, that's good. Now, let's read this information, the notes, and to see whether we can extract certain keywords and to do the same exercise to store it inside that drawer. All right, I'll start with the first one, definition of photoelectric effect. Phenomenon where electrons are emitted, which we call them photoelectrons, from a metal surface when it is illuminated by a beam of light at a certain frequency. Right. Let me help you to understand this very short definition easier with a story. Right. So we are using this to help you to understand this faster. You are holding a torchlight and beam that torchlight on a piece of metal. apparently that metal, that weird metal, is having an eye. You know, the eye that is help you to see things. That metal is also having an eye. When you beam it, immediately that eye from the metal, it pops out. All right.
Okay.
So that story is weird, but it's easy to remember. Easy, have a torchlight, beam the light into the metal's eye, and the eye pops out. Right? So how do you explain this definition? Let's see. The phenomenon, photoelectric effect is a phenomenon where the electron is the eye, as it's mentioned here. Electrons are emitted, right? The eye pops out. Why do I emphasize pops out? Because the electron that is emitted is called photoelectron. So it sounds like pops out electron or pops out the eye, right? From where? From a metal surface. So the metal surface. And how is it being pops out? Excuse me. When it is illuminated by a beam of light at a certain frequency. So it is being using the torchlight with the beam of light at a certain frequency, which means you are vibrating the torchlight at a certain frequency, and you are beaming that into that poor metal's eyes, and he pops out. Right? Now, let's read this again by yourself. Once you're done, let me know. You don't need to read out.
Okay.
Now, does it make more sense now?
Yeah.
Right. So it's just, I think, 10 to 20 seconds ago when you read it, it totally doesn't make sense. With the right method, 10 seconds later, it makes sense now. Right. So let's go to the second note. So before that, I want you to pick up the torchlight and pick up that pop out eyes and put it inside your drawer number 2. So your drawer number 2 is no longer empty now. It's having 2 items there. Can you do that? Done?
Yeah.
Okay, characteristics. So there are 4 characteristics. Read it by yourself. You don't need to read it out loud. Once you are done, let me know. And again, you don't need to fully understand it. Just read it for the sake of reading.
Okay. I read it.
Right, that's good. So you have keywords like frequency, you have kinetic energy. You know what is kinetic energy?
Yeah.
All right, good. So you know, then there is a threshold, frequency threshold, then you have intensity, then you have instantaneous emission. So those are the keywords. And it's very difficult to associate them right now. So let's not kill ourselves. Let's just imagine something lighter. Characteristic. Characteristic is like character. So there are 4 cartoon characters, whichever characters that you like, right? Whether it's a Pokemon character or whether it's a Spider-Man character, doesn't matter, right? Whether it's an unknown character, it also doesn't matter. So there are 4 cartoon characters, and even without you picking them up, they jump into your second drawer. Why do I mention jump? Because there is kinetic energy and there is frequency. You see, frequency, kinetic energy, and maybe intensity and threshold of frequency, they are instantaneous, like instantaneous. They are pretty much can be associated easily with the word jump, right? So 4 cartoon characters jump into your second drawer. So next one, let's read it in a few seconds by yourself.
Okay.
Okay, higher intensity, brighter light, bigger current. So I will imagine there is a bigger torchlight now, and the bigger torchlight is brighter and is more powerful, right? So intensity equivalent to the more powerful with stronger current. So drawer 2 has, what do you have inside? You have a torchlight. you have a pop-out eyes. You have 4 cartoon characters jump into the drawer. You have a big bright torchlight. Okay, so close
Yeah.
that drawer. Now move to the third drawer. What is the label that you see on the door?
Einstein.
Right. What is the name of that drawer?
Einstein's photoelectric theory.
Excellent. So now let's repeat the same task. Let's read this and do this, right? Intentionally store the new information inside the drawer using keywords. For now, using keywords. The following steps will not be as easy. It's not only keywords, it's the understanding. But let's worry about that later. Now, okay, you can read this. I think let's take 10, 20 seconds to read it. Once you are done, you let me know.
Okay. Okay.
All right. I'll get some keywords. Okay, this one I'll do it faster because you already done number 1 and number 2 drawer. So I'll tell you usually how is the normal speed of doing this. Book function. I'll take book function as the keywords. I'll take kinetic energy as the keywords. Then maybe I'll take application as the second drawer, second sub drawer. You can actually do it divide them into sub drawers. For example, drawer number 1, you have 5 sub drawers or 5 items. It's really up to you, whichever makes sense for you. Then drawer number 2, you have 2 or 3. Number 3, you have 3 sub drawers. Drawer number 2, you have 2 sub drawers. So let's focus on drawer number 3 now. Drawer number 1, sub drawer number 1, you have work function. And you have kinetic energy. How do I turn that into an item, or how to turn that into a story? I'll turn that into a story for this case. Think of it, the work function or the keyword, the work is your homework. And think of it that you are walking to your classroom to do the homework. Do you like to do homework? You're excited to do homework, or you are feeling the anxiety when you think about homework? Which one are you? Anxiety or
I don't
excitement?
like doing homework.
You don't like, okay, anxiety, okay, you don't like, you just hate it, right? So easy, feeling very heavy, feeling very the anxiety in your heart, and going into the classroom to do homework, right? Remember, number 2, information plus emotion equivalent to long-term memory, right? So this is what we are doing here. So easy to the classroom, doing what? Doing homework. Why to the classroom? Because when you move from one place to another place, there is a kinetic energy. So that is the keywords I want you to remember. Then why homework? Because there's a keyword work here, right? You definitely do not know what is work function, the definition of work function right now. Don't worry, just remember the work, the terms work. Okay, that's it. Very simple story. Let's move to the next one. Applications. Application, I think it's easy to remember. Solar panels or solar cells and automatic door. No story needed. So drawer 3 now has a story. Easy walking to the classroom to do homework, a solar panel inside the drawer, and an automatic door sensor inside the drawer. Let's close that drawer. Now, step out a bit and see your drawers. Overall, you have 3 drawers, 3 nice drawers with 3 stickers. And as you can see, drawer number 1 is more crowded, it's more heavy compared to drawer number 2, and drawer number 2 is also heavier than drawer number 3, right? So I want you to open the first drawer door and tell me, what do you see inside?
From memory or
No. Can be from memory, is really up to you. Can be reading the notes.
okay, so there's black body inside. there's a UV light. There's a bunch of scientists, and there's a proton car. Oh, and there's a proton car. Oh, oh yeah, and there's a double-sided coin with a wave and colored balls on the other side of the coin.
Yes, which represent the particles.
Yeah.
Okay, let's close that drawer now. Say bye-bye to all the scientists. Close the drawer. Now I need to open the second drawer. Tell me, what do you see inside?
So there's a piece of metal with an eye which pops out when a light is shined on it. Then you have 4 cartoon characters, which are jumping. And then a bigger, brighter light torch.
Excellent. Close that door. Say goodbye to your 4 cartoon characters and open the third drawer. Tell me, what do you see inside?
I'm going to class to do my homework, and I feel an anxiety, so I'm going slowly. And then I see a solar panel, and then I see doors which open when I step close to them.
Excellent. So to do a very quick recap, drawer 1 with the light bulb sticker, you have black body, UV device, scientist, proton car, 2-sided coin. Drawer 2 with the thunderbolt or lightning bolt, torch, pop-out eyes, metal, 4 cartoon character jumping, a bigger torch. Drawer 3, the Einstein, the big nose guy, easy walking to the classroom, solar panel, automatic door. And that's it. Step 2 completed. We have filled all 3 drawers with keywords and images and story. In the next step, we are going to build on this foundation, and let's complete this step 2 by label it as done. Now, next, step number 3. Step number 3, number 4, and number 5 requires a bit of reading, but don't worry, we'll go through this together. Okay. Now is number 2. Let me just pull out my notes and go to step number 2. Which step is this? I think somewhere here. Okay, step number 3, actually, sorry. Step number 3, reading the summary. Okay, how do you read this? Okay, the technique. The techniques, how do you read this? Let me pull this out. Okay, let's focus on this small window. Okay, let's focus on this small window. Let me overlap here. I'll put it over here. And let me pull this out here. Yes, okay, step 3. You're still with me? Your attention span is still here with me? Okay. Yeah. Another slightly more than 1 hour, you'll be getting the full knowledge and understanding of the quantum physics. So bear with me, even if you are so tired or you don't feel like going further, just bear with me. Another 1 hour, right? Just 1 hour. Read summary. What is the skill that we are trying to do here? The trainable skill number 3. Remember the trainable skill number 3? Store new information. Store new information. How do we do that? You need to read the notes, which is the one that's behind this document, which is this one. You need to identify which drawer or even sub-drawer, if you already have a clear idea about the sub-drawers it belongs to. You need to ask yourself, is this new information or is a new understanding? What's the difference between information and understanding? Information is something that you can take it out like a keywords, just like what we did just now. Understanding is you understand those sentence now or those concept now better, right? But it's not easy for you to formalize it into like an image or a device or something that you can easily just pick and put it into the drawer. But you can pick intentionally that understanding, whichever form it is, a gas form, a liquid form, or a solid form, doesn't matter, and intentionally put it into the drawer, right? Later you understand what I'm trying to say here, right? Yes. So I'll put this technique here. Now there is this note. If you see step 3, read summary, quantum theory of light, black body radiations. So how do you do this? Let me just organize it in a better way so you can see it better. Right here. Right. So there are 3 screens over here. I hope it's not too heavy, right? And it's not too messy. So there's screen number 1 that you need to focus on, which is here. Number 2, which is the keynotes. Those are the 2 very important screen that you need to be focusing on. Number 3 is these techniques. So how do you read this? This is to tell you how do you read this. There are the techniques. So let's go through it one time. Then you understand what I'm trying to do here. Read summary. We'll be reading this. The quantum theory of light, black body radiations. Then you'll be reading this. The black body is an idealized object that absorbs all. Wait, let me zoom out. Okay, all idealized object that absorb all incident electromagnetic radiations and emits thermal radiation depending on its temperature. Then you have all these informations. Okay. While you are reading this, you need to intentionally link this to the drawers, right? So you see this technique. Technique number 1, read the notes, which is what we did just now. Step 2 in this technique is identify which drawer or which sub-drawer it belongs to. So can you tell me which drawer or which sub-drawer it belongs to?
It goes to the light bulb drawer and then into the black body.
Excellent. Right. Then once you read this, okay, let's take 10-20 seconds to read it by yourself, right? To read it out loud from the black body until the wavelengths. Let's do that.
A black body is an idealized object that absorbs all incident
You can read it out
electromagnetic
loud, or you
radiation.
can read it out
Oh,
without reading out. Up to you.
okay. Okay, I read it all.
Right. So you need to follow the techniques. Ask, is there new information while you're reading? Ask, is there new information or new understanding? I'm sure there is many new information and new understanding that you got from by just reading from this black body until the wavelength. Am I right?
Yeah.
Right. So put that information and new understanding to the black body drawer. Okay.
Okay.
Done. Now
Yeah.
read this keynote again and see whether you understand it better than 10 minutes ago when you read the keynotes just now.
Yeah, I do.
Right. Okay. So that is the thing that we are trying to do here. We are trying to increase the understanding more and more and increase the new information more and more, right? To train that skill, the skill of storing new information in the right drawer, in the right place, right? So this will be the same technique that we are going to repeat all over again, but with different notes. Okay. Now let's go to this table. I'll give you, let's read it by yourself and tell me when you are ready. But before that, sorry, you need to intentionally do this skill every time when you read this, or do these techniques every time when you read this. Okay. So
Okay.
you can start now. I'll come back in 10 seconds. I'm back. Let me know when you're done.
Okay.
Okay. If I'm an Asian student, I'm not sure how your school teach you to learn to be exam ready. If I'm an Asian student, I'll be very worried when I see this table. Why? Because when I see this table, it tells me that I need to memorize all the scientists' names, and I need to memorize the sequence. I need to memorize the year, and also I need to memorize what contribution they did to the science, to the classical science and to the quantum science. Do you have the same feeling?
Yeah.
Okay, this is the wrong way of studying. So I'll tell you the fact is, if I was that Asian student before, I'll take maybe 2-3 hours just to do the thing that I told you just now. And unfortunately, after 2-3 days, I will forget like 50% of it. So you are just wasting your time. You remember I told you that 200 hours, how much solid time that you actually use it efficiently? Definitely not more than 100. This is where we are trying to change the way you study. With the right method, you see the right result. How do you study this table? Don't worry too much. Again, don't worry too much about the content. Just know that, okay, there is a bunch of scientists that was in your first drawer, and they are some is the oldest one is Isaac Newton, 1704. The youngest is Louis Broglie. Albert Einstein is somewhere in the middle. Max Planck is somewhere in the middle, right? And there are two columns over here. There are contributions towards classical physics and contributions towards quantum physics. So when you see over here, you see that there is nothing contributed and there's nothing contributed. Reason is because classical physics is having flaws. So let's go back to subdrawer number 2. Now this makes a bit more sense. It's having flaws that the scientists eventually discovered. And once they discover the flaws, and it's a big flaws that they discover, and that's the birth of quantum physics. That's the birth of quantum physics. When was it done? Circa around the year of 1900 by Max Planck, right? Because you see, John and Thomson, they were trying, but they failed. So Max Planck built on top of the failure that the previous scientist was building, and revolutionized and give birth to this what we call quantum physics. And then moving on, all these very smart top scientists are contributing continuously towards quantum physics. That's where and why we are sitting here today in the morning to learn quantum physics. Right. That's all you need to know. You don't need to remember this formula, don't need to memorize it by heart. You know it later in 1 hour, right? So that's how you read this table, all right? So and this table is which drawer? Drawer number 1 and subdrawer number 2 and 3. Yes, it's not only related to one particular drawer. It can be one to many drawers. For this case is the subdrawer number 2 and subdrawer number 3 for the first drawer, the quantum theory of light. Now, let's continue. Yes, let's do the same drill. Read with this technique and then tell me when you're done. Let's start now.
Okay, I read it all and like put it into the
Right, so
drawers.
I believe you have identified some new understanding and put it inside your drawer, right?
Yeah.
So you have the quantum energy, discrete packet of energy, and maybe you have some keywords that you want to put inside the drawer. Now, read back this quantum energy. Okay, and then once you're ready, let me know. Just display.
Okay.
All right.
Yeah.
Okay. So once you read this, does it give you a little bit more of the understanding compared to when you were in step 2 just now? Now we are in step 3.
Yeah.
Okay, that's it. Let's continue using this technique for these nodes, wave particle duality. Let's start. Let me just, adjust it. Yeah, let's start now. Until here. Yeah.
Okay.
Okay, small task. What drawer is this?
The light bulb. And it's the double-sided
Okay,
coin with the wave and the particles.
right. So by now, maybe you'll be able to appreciate this better now. It tells us that the light is exhibiting two properties, the wave properties and the particles properties. So what is the wave properties? Things like, the diffraction interference, and particle properties are the photons, where you have momentum and kinetic energy and they can collide with each other, right? So let's imagine now you have a ball in front of you that you're holding a ball. It is definitely having the properties that's related to kinetic energy. You can move the ball and there's momentum, and when you throw the ball, there's a momentum, it will bounce back from the wall, right? But you cannot imagine that the ball is having wave property. You cannot diffract or make interference for the ball, right? Do you know what is
Yeah.
diffraction?
Not interference.
All right, interference. Okay, then let's focus on diffractions. Right.
Oh, no, I don't know that
Diffraction is
either.
like, you don't know that either. Okay, like a wave, when you make a wave and the wave is going to expand, right? Expand. When you put something right in the middle to obstruct it, then it will the pattern of expansion, the wave, is going to be distracted, and it will turn into another shape. So that is diffractions, in a simple word, right? But when the ball, if you push the ball to this obstacle, it reflect back. It doesn't diffract. It doesn't change into another form. Does it make sense?
Yeah.
Right. So the wave is able to change into another form when it hits some obstacle, but particles, it doesn't. It return back. But what this wave particle duality is trying to tell us is light is exhibiting two properties, the wave property and also particle properties. Okay? The scientist is telling us, the D. Broglie is telling us, and also the quantum physics scientists like Albert Einstein, they are telling us every object in the world is having two properties, wave and particles. Even the mic that is in front of you, even yourself, anything that is in front of you that you see. But because our mass is too big, we are too heavy, the wavelength is too small. So we do not easily observe our wave properties. However, if you go to the quantum matter, which is the photon, the electrons, the subatomic matters, their mass is much, much, much smaller, and their wavelength is much higher, and that's where they can exhibit the wave properties. It's a bit abstract here. Are you following me? Do you think you're following me 100% or 80% or 10%?
Like 80%.
80%. Good. 80% is very good for step 3. You will pick up the remaining of the 20% as we go along. Okay? So pick this information and pick this understanding, put it inside your drawer. Right? Like I say, it is no longer as easy as just imagining it as 4 characters, 4 cartoon characters, or a black body or a UV device. Now it's more about the concept. So how do you pick this up? Well, if it's as easy as formalize it into some image that you can pick it up and put it into your drawer, do so. If not, the intention of doing that, picking up those things that I told you just now and put it inside the drawer itself, is already good enough. So you know that there is something that you fill up into the drawer. Okay?
Okay.
Am I too abstract or is clear?
No, it's fine.
It's fine. Okay, good. Let's continue here with the same technique. Let me know when you're done.
Yeah, I'm done.
All right. So new information, new understanding, put it inside that drawer. Which drawer is this?
The second drawer. The one with the lightning bolt.
All right. Okay. So let's continue. Move to this one. Let's start.
Okay.
All right. I think
Yeah.
there is a new understanding. Just appreciate and try to understand this. A photon transfers all its energy to a single electron. Right? Photon transfer the energy to a single electron. Right? Yep. Let's put that into your drawers. Which drawer is this?
The lightning bolt, and I don't want to go to my class and do homework.
Is that lightning bolt?
Yeah, lightning. Wait, is it?
Are you
No, no,
sure?
no. It's not. It's the Einstein.
All right. That's the third drawer. Okay. The third drawer. Good. Okay. Let's read this quickly and let me know when you're done.
Okay.
All right. So work function. I think this is a new understanding. Now this work function is no longer the homework that you know. It's the minimum energy required to release an electron. Right? Minimum energy required to release an electron. That is the work function. It's like you need to pay a ticket to go to somewhere. You need to pay a ticket to fly from Saudi back to New Zealand. Right? So there's a minimum cost that is needed. Without that money, without that energy, you cannot fly. The electron cannot emit out, right? So next, let's start.
Okay.
Right. Do you do this intentionally, this technique?
Yeah.
Okay, then tell me which drawer.
The third one with Einstein.
Right, what's the name of the drawer?
Photoelectric theory. Einstein.
Excellent. Right, so how do you explain this equation? It's very simple. Photon energy, remember the torchlight, the beam of light, and that is the photon energy, and it's beam towards this metal, the metal surface, and the electron is being emitted, the eye is being popped out, right? So remember, there's a work function. It doesn't mean that any light that is shown, that is beamed onto the metal surface, it will pop out or you emit the electrons. You need to have a minimum requirement, and it's called the work function. That means the minimum energy. Here, go back here. The minimum energy required to release an electron, right? Then the remaining energy after you pay this minimum energy that to release the work function, or release the electron, is the kinetic energy of the photoelectron, right? Does it make sense now?
I think so.
Right. Let me put it in another way. You have 100 real you need to pay 30 real to buy your flight ticket to fly. And the remaining is 70 real. Because energy doesn't distort, doesn't go, energy transfer their form. They do not lose their energy. So the energy of photon is 100 real, and then you need to pay the 30 real to fly, which is the work function, the minimum energy that is required. Then the remaining of the 70 is the kinetic energy. So 70 means compared to, let's say, 50, 70 means you are having more kinetic energy, you're moving faster compared to if it is 50, right? If the work function is 50, then obviously you get only 50. If the work function is 30, then you get 70, and so on and so forth, right? And photoelectron, what is the difference between photoelectron and electron? The difference here is electron is the one that is still not being emitted. The one that is being emitted, that pops out electron, is called photoelectrons, right? That's why I intentionally emphasize the word pops out, right? It sounds like photo, okay? It's just the way I try to associate it easier, right? So that's the difference between photoelectron and electron. Now, the last part here, let's read this quickly.
Okay.
All right, so this is drawer number 3 and subdrawer number 2. Now, let's recap very quickly. Drawer number 1, the light bulb, which is called the quantum theory of light. You have the black body, you have the spectrum, you have the UV catastrophe, you have the scientist, you have the proton car, you have the two-sided coins. Drawer number 2, the thunderbolt, what's the name? The photoelectric effect. You have the torch, you have the pop-out light, you have the cartoon character, 4 of them jumping, and a brighter torchlight. Drawer number 3, the Einstein face, the big nose face. You have the easy going to the classroom to do the homework, and you have the solar panel, and you have the automatic doors. Of course, you have more things now because the understanding that we cannot translate into something, an item, is already inside your drawer. Right, so that is step 3. Halas, completed. You have now linked the summary, the notes in the summary, to your drawers. In step 4, we are going deeper to apply and reinforcing this idea. All right, so this we have. Where's the step tracker? Where's the step tracker? I think it's here. Yes, the step tracker. Halas, done. Next is the FAQ. What time did we start? We start about 1 hour ago, and we are almost there, right? We are 40%, 40%. Okay, so just bear with me. Are you still with me?
Yeah.
You still want to continue?
Yeah.
What does it mean? It means
Yeah.
you're
Yeah.
excited? Yes. Okay, good,
Yeah.
good. Just bear with me for another, maybe slightly more than 1 hour, right? Slightly more than 1 hour. Bear with me. Right, okay. So how do you read these notes? Step 4, I want you to read this using these techniques. Read the questions, identify which drawer it belongs to, read the answer. Then ask yourself if there is new information or new understanding, and then if yes, place it into the correct drawer. There are only 8 of them. So let's go one by one now, quickly. And then you can also associate it with your keynotes. That's why I always keep the keynotes next to you. All right, let me just make it better. Yep. Okay, let's start. You can start now.
Okay.
All right, new information, new understanding, put it inside your drawer. Drawer number 1, theory of light. Subdrawer number 1 and 2, black body and classic theory flaws. Right? So this Max Planck is the birth of quantum physics. Now next. Let's start.
Okay.
Right? Same thing, new information, new understanding, put it inside your drawer. Number 3, let's start.
Okay.
All right, which drawer is this? Which sub-drawers?
The double-sided coin.
Excellent. Let's move to the next one. Okay, let's start.
Okay.
New information, new understanding, put it inside your lovely drawer. Let's move. Number 5, let's start.
Okay.
Right, this is drawer number 3, Einstein photoelectric theory. Number 6, let's start.
Okay.
All right, let me pause a bit here. There's a new understanding, I believe. Metal with higher work functions requires higher threshold frequencies. What does it mean? Which drawer is this? Drawer number 3, right?
Yeah.
Drawer number 3, the Einstein photoelectric theory. Yes. And we explained just now on the work function, and also we explained just now on the maximum kinetic energy, that this one, right? So there is a different metal will have different work function. So different metal will require different minimum energy to emit the electrons into photoelectrons. Like different airlines will have different price in their flight ticket. Okay, so that is the new. I think there is a new information or new understanding. You need to put that into your third drawer. Let's move on. Okay, number 7, start please.
Okay.
Okay, last one. Let's start.
Okay.
All right. You might be asking whether I should put the quantum computer and those secure encryption signatures, image sensor inside the drawer and put it as an item. For this type of questions or this type of notes, I will not make my drawer too crowded because it's just example. I will just put 1 or 2 examples, and from there, I think I'll be able to associate it with the other examples easily, right? Else you'll
Yeah.
be always opening up the drawer and see so many items over there, and by the time you list down all these examples, you already forgot, you already passed your exam time, right? Now, we have
Okay.
done step 4. Okay, where is that tracker? I like the tracker. Halas. Step 4, halas. Before we move to step 5, let's read these keynotes again. Remember the keynotes was in step 2, right? Step 2. That was about 1 hour ago. And when you read it, you have almost no idea what it tells you. Now, let's take a few 1 minute to read it and see whether you can appreciate the notes better now. Let's start.
Okay.
All right. So do you have the same feeling that I told you just now? You can understand the notes better now.
Yeah.
It's the same note. We did not change any words from there, but just you go through from step 1 to step 4. Now the concept start to build inside your brain. Okay, that's a good sign. Let's continue. Step 5, we haven't finished. Where is it? Step 5. Let's go to the technique first. This is the technique. And step 5 is read the guide and quiz. Right, so there are 2 parts over here. Let me move to the guide. Right. So how do you do this? Part 1 is reading the guide. Part 2 is reading the quiz. So part 1 is the same. Okay, this is for reading the quiz. Okay, don't worry about this first. Part 1 is reading the guide. It's the same technique like previously. You read the notes, you identify which drawer, you ask if there's new understanding, and place it to the right drawer. Okay, something similar to step 3. Are we ready?
Yeah.
Okay, let's do this. Let's start this. Yep. Let me know when you're done.
I'm done.
Okay, let's move to the second part. Let's start now.
Okay.
Okay, these are still in drawer number 1. Okay, let's start
Yeah.
here. This is the proton car.
Yeah.
Done?
Yeah.
Okay, this is the coin.
Okay.
All right. So far, is there any new understanding that you discover?
Um,
Not so
not
much.
really. Mm.
Not really. Yes, good. Which is good. Okay. Drawer number 2.
Okay.
Drawer number 3. Wait, I'll come back in 10 seconds. Sorry, I'm back. Let's
Okay.
move. Okay,
Yep.
here. Yep.
Okay.
Okay, here.
Okay.
Right. So far we have been doing almost the same trainable skill, which is to read, to identify which drawer, and also to find new understanding and then place it to the right drawer. This reading and placing is how we train ourselves to learn like A student, a more organized student, rather than a B student which randomly unstructured put those information wherever he or she wants and he or she needs. And when you need to retrieve these informations, you have this cognitive fatigue. It's very difficult for you to retrieve these informations. And then you'll be reluctant to absorb new information because imagine you have your information database is so messy, you cannot even manage the existing information or knowledge that is inside yourself. And every time when you want to retrieve any information that you think is inside your database, it's so difficult, right? It's so hard to get it. Then you form a wall unintentionally to stop new information from coming in. That is the reason why the 200 hours example, even you spend 200 hours because you have this mental blocking that is blocking you from absorbing this new information because your mental, your brain has, your mind has been telling you that stop getting more information because the existing information itself, you are unable to make full use of it, and it's so difficult for you to retrieve any information. There is this cognitive fatigue that you are trying to solve, right? Does it make sense?
Yeah.
Right. So that's why we constantly want you to identify which drawer and put it into the right drawers. Right. So let's go to the quiz question. Quiz question is a, a bit new to test or to train different type of skill set. Right. Remember the trainable skill number two here, let me see. Yeah, number 2, fast recall. Fast recall. You need to train your muscle memory to do it fast and by yourself automatically. So how do we do that? Let's see the technique. You read each question. Quiz, there are 10 small short questions. Yeah, you read each question, the short question. Then I need you to identify the drawer. And then before reading the answer, I need you to refer back to the keynotes or your own drawer. What are the key informations that you can take it out and form as a short answer? You don't need to form as a very long answer like you're trying to answer for an exam question. Any point forms, answers, roughly how this answer should be is enough. Are you following me?
Yeah.
All right. So that first exercise, by just reading the question and doing this thing, is to train the speed number 2. After that, every question I will review the answer. And that answer, you will train the normal drill that we have done. You see whether there is new information or new understanding that you have, and you put it back to the right drawer. Right. So the quiz is going to train you on all 3 trainable skills: number 2, number 3, and number 1. All right. So let's start. Let's start number 1. You can start by reading number 1 now. Okay, I think let me guide you because this is new. Let's start by doing it together. What you see, each question I have to identify which drawer, so I have to read the questions. What is a black body? How did classical physics fail to explain this spectrum? So number 1, this is drawer number 1, which is the quantum theory of light, and subdrawer number 1, and also number 2, because it's talking about field for the classical physics. So we have the black body and we have the ultraviolet. And now recall the keywords. So what are the keywords that you have here or inside your own drawer? You can explain the black body is absorbing all the electromagnetic radiations and then is emitting the emission on high frequency when it is hot and shorter wavelength. And then you can explain why is it fail. You can mention the ultraviolet catastrophe. What does it mean? It means that it predicted unlimited energy at a higher frequency, but the experiments later show that it wasn't true. And that is the flaws of the classical theory of this classical physics theory. Right. So this is to train the recall speed. Whether your answer is 100% correct or not, it doesn't really matter. What it matters is to train the recall speed of the information. Right. And you can add in more information if you have it inside your drawer, because for the past few steps, you have already add in new understanding inside your drawer. So your drawer is not exactly the same as my drawer. Right. Then you can put in those information into it. Now, let's go to this one. Then after you have already formed some level of your answer just now, then you try to compare it with the right answer and see whether there is new understanding that you can pick it up and put it inside your first drawer. Let's see. So answer number 1 is this: black body. A black body is an idealized object that absorbs all incident electromagnetic radiation and emits thermal radiation based on its temperature. Classical physics predicts radiation intensity would rise indefinitely at higher frequency, ultraviolet catastrophe, but experiments show intensity peaks when decreased. Excellent. I think the answer is exactly as mentioned over here. And there is no new information, there's no new understanding, right? Maybe how you write it. If I want you to train you to be exam ready, then you might need to be able to eventually write in this type of sentences. But now let's forget about that. Our objective in these 2 hours is not to make you exam ready. Our objective in these 2 hours is to make you to understand the concept really, really well. Right? Exam ready is another time. Right? Yeah. Yeah. Okay. Do you follow me?
Yeah.
Yeah. Okay. So this is the first example. First questions. We have 9 more questions to do. Let's repeat this drill by yourself. Let me know when you finish reading this and associating which drawer, and in your mind you already have some level of informations to form your answers. Let's do it now. Let's start.
Okay.
All right, so let's see, compare the answer. Done?
Yeah.
Okay. New information, new understanding, put it inside your drawer. Then we'll move on. Number 3, third question.
Okay.
All right, so let's compare your answer with his answer.
Okay.
All right. Number 4, double-sided coin.
Okay.
Okay, let's compare the answers.
Okay.
Number 5, drawer number 2.
Yeah.
Compare the answers.
Yeah.
Number 6, explain the concept. Drawer number 2.
Okay.
Compare the answer.
Yeah.
Number 7, intensity. This is a tricky question.
Okay.
All right, let's see. Where is it? This one, number 7.
Yeah.
Okay, let me explain this a bit. The intensity increases the number of photoelectrons emitted, so higher current. However, for kinetic energy, Kmax, it remains unchanged. Why? It's because if you see in these drawers, you have kinetic energy does not depend on the intensity. So no matter how intense is the light, the energy, it doesn't matter. It will not change the kinetic energy of the photoelectron. It will only change the current, make the light brighter. All right, next. Do you understand this?
Yeah.
Or a little bit? Okay, good. Going to number 8, Einstein, drawer 3.
Okay.
Compare answers.
Okay.
Okay, number 9, also drawer 3.
Okay.
Let's compare the answer.
Okay.
Right. This W is work function. Higher work functions means higher frequency. Higher work functions
Yeah.
on the previous example is the flight ticket. The flight ticket is more expensive, then you need to pay more. Number 10, last one. Why? We're almost there. Yeah. This is the easy one.
Yeah. Okay.
Super duper easy. Let's see. Done? Alas, I like
Yeah.
the tracker. Let's go to the tracker. Where is the tracker? Go to the tracker. Okay. Now we complete the heavy lifting. The rest is easy. Now, we started 7:18, and now it's less than 2 hours, slightly more than 1.5 hours. Do you think that you can understand what quantum physics now? If somebody asks you to explain in a very short, right?
Yeah.
Hello? Yes. So let's do a comparison. Easy, which is student B 2 hours ago. Easy, who is becoming student A 2 hours later. Easy, who is student B, how much do you think you'll be able to understand if I give you a book that is related to quantum physics, 50 pages, in 1 hour or in 1.5 hours? Right. I
Like,
don't think you'll be understanding as much as you know right now. Do you have
yeah.
the same feeling? Right, you have the same
Yeah.
feeling. Good, good. So do you agree that this will reduce the chances of procrastination?
Yeah, I think so. Because it's like less, you don't have to do that much. It's just like
Yes,
you have a
it
smaller goal.
exactly. Yes, you point to the two right goals. One is it takes less to do, and it doesn't need you to do much. In fact, you did not do too much, right? You just need to follow the steps. Of course, you cannot just sit down there and press a button and then you get all the informations. You need to do some work, but that amount of work is not too much. It's bearable, right? And it will be more and more bearable when you make it into a habit. This is the first time, and the first time usually is the hardest. And even that this first time that we are going through this session, you feel it that it's not too much, right? And you, most importantly, you see the result. You spend these 2 hours, you get this result. Compared to you spend these 200 hours and you hope that and you pray God that you're gonna get this output, right? So success is no longer by chance. With the right method, success is a matter of time. For this case, it's only 2 hours per chapter. All right, let's move back. Move back. Yes, this is the easy part. Step 6, watch a video. Now, everything there is a technique, right? Watch video also we have a technique that you need to follow. So what is the technique? You remember the flying brain problem that everyone has? Remember that?
Yeah.
That your brain is being distracted. You have to go out to buy something. You have to do this. You have to do that. Oh, you've forgotten to do this. Oh, next week you have to plan for this trip. So many things because our brain is just too distracted and too busy with so many things. So we need to move them back their focus to the moment that we are now. So how to do that intentionally? You need to always link it to the drawers, right? When you watch the video is about 7 minutes long. You have 7 minutes. Can you commit that you're going to focus for the 7 minutes?
Yeah.
Say yes. Okay. And whenever you see the video with new information or new slide, because it's like a PowerPoint with many slides for 7 minutes, I want you to intentionally link that particular information to which drawer that you have in mind. If you can link that to which sub drawer, that is even better. Unfortunately, I will not be able to show you the keynotes because the video is a full screen. You're going to see one screen, right? Can we do that?
Yeah.
7 minutes, fully dedicated and linking each points, each new informations or even existing informations to the drawer that you have in your mind, that you have built. Let's do that.
So what if I told you?
Can you see and can you hear? Hello? Hello, Easy?
Sorry, I accidentally turned off my mic. Yeah, I can see it and hear it.
You can hear that
Yes.
the person who is trying to, yeah. Okay, let's start. I'll turn off my mic.
You that the solid, predictable world you see all around you is, well, it's basically just an illusion. Today, we're diving headfirst into quantum physics. It's the story of how science found out that at the very smallest scales, reality starts breaking all the rules we thought we knew. And it all kicks off with a question that sounds pretty simple, right? But the answer would end up tearing the entire world of physics in two.
Okay, I'll disturb you for a while. This one, if I'm you, I'll say that, okay, this is related to drawer number 1, subdrawer number 5, the coin, the wave and particle, properties. Okay?
Okay.
Then when you see the next one, then you do the same thing. You see the next one, you do the same thing until the 7 minutes video is finished. Let's do that.
For centuries, people thought the debate was settled, but it turns out really wrestling with the true nature of light would completely shatter our view of the universe. Okay, so let's set the scene. Picture this, it's the year 1900. And physics, well, it feels kind of complete. We've got Newton's laws running the show for motion, Maxwell's equations of electromagnetism all figured out. It really seemed like we had the universe's instruction manual just about finished. And a huge piece of this perfect puzzle was light. Thanks to guys like Thomas Young and his famous double-slit experiment way back in 1801, the science was settled. Light was a wave, period. It flowed, it rippled, it spread out. And energy was the same way, smooth, continuous, not chunky. It all just made perfect logical sense, or so.
Sorry, let me disturb you again. You need to do 2 things. The first thing that I mentioned to you just now, the flying brain problem, you need to solve it by linking it with the drawers. Number 2 is continue to identify new information or new understanding and then put it back to the right drawer. Okay, 2 things you need to do. Just focus on the 2 things for another 6 minutes.
Everyone thought.
Okay.
But see, that's the thing about science, right? You have to keep testing your ideas. And as our experiments got more and more precise, we started seeing things that the old rules just couldn't explain. That beautiful, perfect picture of the universe was starting to show some pretty serious cracks.
The first big crack came from studying something with a kind of weird name, a black body. Now, don't let the name fool you, it's not always black. A black body is just a theoretical, perfect object that absorbs and emits radiation. A better way to think about it is the glowing red heating element on a stove, or even a star. As they get hotter, they glow. And the light they give off is based purely on their temperature.
And this is exactly where the old rules went completely off the rails. According to classical physics, as a black body gets hotter and hotter, it should spit out more and more high-frequency light, like ultraviolet, basically shooting off towards infinity. But that's not what happened in the real world at all. Experiments showed the radiation hit a peak, and then weirdly, it dropped off. The theory was so wrong, so spectacularly wrong, they nicknamed it the ultra-catastrophe. The rulebook was officially broken.
So the ultraviolet catastrophe was a total dead end. It was a brick wall for classical physics. To get past it, the solution required a completely new, and frankly, a very, very weird way of thinking about the most basic thing in the universe, energy itself.
So in 1900, this physicist named Max Planck came up with a solution that he himself called an act of desperation. He just threw out this idea, what if energy wasn't smooth and continuous? What if it could only exist in tiny, separate little packets? He called them quanta. It was a total guess, really, just a mathematical trick to make the problem go away. But when he plugged it in, the ultraviolet catastrophe vanished. The math worked perfectly. He had accidentally stumbled upon a brand new fundamental rule of the universe.
And just look how fast the dominoes fell after that. Planck's act of desperation in 1900 wasn't the end of the story. It was the starting gun. Only 5 years later, a young patent clerk named Albert Einstein takes this quanta idea and just runs with it. Then, less than 20 years after that, Louis de Broglie flips the whole thing on its head. We're talking about a complete revolution in how we see reality, all within a single generation. You see, Einstein saw Planck's quanta and thought, hey, maybe this isn't just a math trick. Maybe it's a clue to another big mystery, the photoelectric effect. Now, the observation here is simple. You shine a light on a piece of metal, and sometimes it knocks electrons loose. Sounds pretty straightforward, doesn't it? But, as you can probably guess, the details made absolutely zero sense under the old rules.
The experiment itself couldn't be simpler. You've got light hitting a piece of metal, electrons fly off, and those moving electrons create a current you can measure. Easy. But the results from this incredibly simple experiment were about to cause a massive headache for the whole light is a wave idea.
Here we go again. The classical wave theory just completely fell apart. It predicted that any light, as long as it was bright enough, would eventually build up enough energy to knock an electron out. But the experiments showed something totally different. Below a certain threshold frequency, nothing happened. You could shine the brightest light in the world on it, and not a single electron would budge. And even weirder, when it did work, the electrons flew off instantly. No delay. It was like they were getting hit by a tiny bullet, not being washed away by a slowly building wave.
And this is where Einstein had his incredible flash of genius. He took Planck's quanta and applied it to light. He said, forget the continuous wave. Light is actually a stream of these tiny energy packets. He called them photons. And just like that, everything clicked. A single photon hits a single electron. If that one photon has enough energy, which means it has a high enough frequency, bam, it kicks the electron out instantly. If it doesn't, nothing happens. It's not about the overall brightness, it's about the punch packed by each individual particle of light.
So, wait a second. Is light a wave, which explains stuff like diffraction, or is it a particle, which explains the photoelectric effect? Which one is it? And the answer, incredibly, is yes, it's both. And right here, this is the weird beating heart of quantum mechanics.
I mean, on the one hand, the evidence for light being a wave is just undeniable. You shine it through a tiny little slit and it spreads out, creating these interference patterns of light and dark bands. That is textbook 101 classic wave behavior. Case closed, right?
Oh, not so fast. Because this is where reality gets truly, deeply weird. In 1924, Louis de Broglie asks this amazing question. If waves can act like particles, could particles act like waves? So they tested it. They fired electrons, which are definitely tiny little pellets of matter, at a crystal. And what they saw was impossible. They got a diffraction pattern. The electrons were behaving like waves. Just think about that for a second.
A single solid object was somehow interacting with itself as if it were smeared out all over space. And that leads us to the absolute core concept of quantum mechanics, wave-particle duality. It isn't an either-or situation. It is both at the same time. Light, electrons, you, me, everything at this fundamental level exists in this bizarre hybrid state. It only chooses to look like a wave or a particle when we force its hand by measuring it. This is the new rulebook. It's strange, it's counterintuitive, but it's how the universe actually works.
Now, I know what you might be thinking. This all sounds incredibly abstract, maybe a bit of a brain melter. But these weird rules aren't just a curiosity for physicists in a lab. They are, and this is not an exaggeration, foundation of our entire modern world.
So why should you care? Well, the image sensor in your phone's camera, that's the photoelectric effect in action. Solar cells converting sunlight into electricity, that's all about photons. The electron microscopes that let us see viruses and design new medicines, they rely on the wave nature of electrons. And today, we are pushing this weirdness to its limits, building things like quantum computers and unhackable encryption systems. These strange quantum rules are literally the blueprint for our future.
And that leaves us with one final, kind of unsettling thought. The solid, predictable world that our senses show us is really just a high-level summary. Underneath it all, the universe is this shimmering dance of probabilities and possibilities, governed by rules that defy all our everyday intuition. The quantum world isn't a theory about something out there, it's the fundamental reality that we are all made of. And the real question is, what other secrets is it still waiting to reveal? Thanks for joining us.
All right, that is the step number 6. Let's close this. So, do you feel that your flying brain problem reduces?
Yeah.
Yeah, okay. So now let's do listening to the podcast. The technique is also the same. I need you to intentionally associate or link the content that the person who's going to talk about to the drawers.
Okay, let's unpack this. So,
but this will be a bit easier because I'll be showing the keynotes over here, and then I'll be highlighting it to show you which drawer it is now. All right, so it's about also 7 minutes. Can I have full dedication, full focus from you for this 7 minutes?
Yeah.
Right, let's start.
okay, let's unpack this. So, imagine a universe where energy isn't smooth, like a ramp.
Yeah,
But it comes in these tiny, discrete packets, like steps.
exactly. And that's not sci-fi, that's quantum physics. It's kind of the bedrock for, well, so much modern tech.
Yeah, things super fast computers with huge memory
Yeah,
and encryption that's almost impossible to crack. Mind-bending stuff.
it really is. So for this deep dive, we're journeying into how we figured out the basic rules of light matter. This is the quantum era, And understanding this, especially if you're digging into physics, helps you see how we get to quantum computers for tackling huge problems.
Like simulating galaxies or chemical reactions.
Or even the stock market, yeah. Really complex systems.
So our mission today, figure out where these revolutionary ideas came from. And it starts, kind of surprisingly, with the puzzle that stumped everyone back then. Let's talk about the black body. Now, in physics, this isn't always like a black object, right?
Right. It's more of an ideal concept, an object that absorbs all radiation hitting it, and then it radiates energy back out just based on its temperature.
Like a hot piece of metal glowing.
Precisely. Or even us. Humans emit infrared radiation. That's thermal. That's how vision works.
Okay, so what was the puzzle?
Well, the classical physics of the time, it predicted that as these black bodies got hotter, the energy of the light they emit should just keep going up and up as the frequency gets higher, like towards infinitely high energy for ultraviolet light and beyond.
Oh, infinitely high usually means the theory's got a problem.
Bingo. Experiments showed the complete opposite. The intensity peaked and then dropped off sharply at higher frequencies, those shorter wavelengths. It just didn't match.
So the classical picture was broken.
Seriously broken. It was called the ultraviolet catastrophe because the prediction was so catastrophic wrong in the UV range. This was a huge sign something fundamental was missing.
Okay, so who cracks it?
Max Planck. In 1900, he comes up with this, well, this radical idea. He basically said maybe energy isn't emitted continuously. Maybe it comes in little chunks, little packets. He called them quanta.
Quanta, like quantities of energy.
Exactly. And the energy of each quantum, he said, is tied directly to the frequency of the wave, E equals HF, that famous equation.
So higher frequency light means higher energy packets, but maybe fewer of them.
You got it. At a certain temperature, there just isn't enough thermal energy to make lots of those really high energy quanta, so the intensity drops off at high frequencies. It perfectly explained the experimental results.
Wow, so energy isn't a ramp, it's stairs.
That's a great way to put it. It was a fundamental shift. Energy is quantized. Discrete steps. This really kicked off the quantum revolution.
Okay, so Planck quantizes energy emission, but
Yeah.
then Einstein takes it deep, right, with the photoelectric effect.
Yeah, another puzzle classical physics just couldn't handle. The photoelectric effect is when light hits a metal surface and knocks electrons out, photoelectrons.
Simple enough experiment to set up, you'd think.
You would, but the results were bizarre according to classical wave theory. For one, you needed a certain minimum frequency of light, a threshold, electrons out at all. Didn't matter how bright the light was below that frequency.
So a really bright red light wouldn't work, but maybe a dim blue light would.
Exactly. And second, the electrons came out instantly. No delay, even with very faint light. Classical waves should have taken time to build up enough energy to eject an electron.
Okay, what else?
The energy of the ejected electrons depended only on the light's frequency, not its brightness. Brighter light just meant more electrons, faster ones. Classical waves suggested brighter light would mean more magnetic electrons. It was all wrong.
This is where it gets really interesting. So Einstein steps in. What was his big idea?
He took Planck's quanta idea and ran with it. In 1905, he proposed that light itself isn't just a wave, it is these packets. It behaves like a stream of particles. He called them photons.
Light particles.
Yep. Each photon carries a specific energy, E equals HF, just like Planck said. And Einstein used this to explain the photoelectric effect beautifully. See, a single photon hits the metal. If its energy, HEHF, is greater than the energy holding the electron in the metal called the work function, then boom, the electron gets knocked out.
Ah, so that explains the threshold frequency. The photon needs enough energy to pay the exit fee.
Precisely. And any extra energy the photon has beyond that work function becomes the electron's kinetic energy, making it move faster. That's why frequency matters for electron energy, not intensity.
And the instantaneous emission.
Explain too. It's a one photon, one electron interaction. If the photon has enough energy, the ejection happens right away. No need to wait for energy to build up. Einstein nailed it.
Okay, so light is weird. It's a wave, but it's a particles, both.
That's the conclusion. Wave-particle duality for light. But then things got even weirder.
How so?
Well, in 1924, Louis de Broglie asked, if waves can act like particles, maybe particles can act like waves.
Wait, like electrons
Meh.
acting as waves.
Exactly. He proposed that all matter has a wave nature. Everything. You, me, this microphone, electrons.
But I don't see myself diffracting around corners.
No, you don't. De Broglie came up with an equation for the wavelength. Lambda equals h divided by momentum, p, which is mass times velocity. Remember, constant, incredibly tiny. Everyday objects with significant mass, the wavelength is astronomically small, way too small to ever notice.
But for something really small, like an electron.
Ah, now you're talking. Electrons have tiny mass. If you get them moving fast, their de Broglie wavelength becomes measurable. Short, but measurable.
And did they prove this?
They did. In 1927, experiments showed electrons diffracting through crystals, creating interference patterns exactly like light waves would. It was stunning confirmation. Matter behaves like waves.
Wow. So wave-particle duality isn't just for light, it's for everything.
It seems that way. And this isn't just a cool theoretical idea, it's hugely practical.
Like the electron microscope.
That's the perfect example. Because electrons can have wavelengths thousands of times shorter than visible light, electron microscopes use electron beams instead of light beams.
Allowing much higher resolution, right? Seeing much smaller things.
Way smaller. Things like viruses, the detailed structure of cells, stuff you could never see with a regular light microscope. All thanks to the nature of electrons.
So let's recap. We went from a glowing object puzzle
The black body problem, yeah.
to Planck saying energy comes in packets, quanta.
Which solved the black body radiation curve.
Then Einstein saying light is
packets photons.
Solving the photoelectric effect mysteries.
And finally, de Broglie saying even matter, like electrons, has a wave nature.
Confirmed by electron diffraction. It completely rewrote our understanding of reality at the most fundamental level.
So what does it mean for us, for you listening?
Well, it fundamentally challenges our everyday intuition, doesn't it? This idea that things can be both a particle and a wave simultaneously. It's not one or the other, it's somehow both. So maybe a thought to leave you with is, how does this wave-particle duality stretch your understanding of what's real? And thinking about things like electron microscopes or even night vision, what other unexpected doors might this dual nature open up in the future? What tech is waiting just beyond our current view? Keep thinking about it.
All right. So how much time you spend out of the 7 minutes you spend on flying brain?
I'm not
Maybe
sure,
1-2%?
yeah, it wasn't that much because I think that like putting it into the drawers helps to just we need to think about it more.
Excellent. Yes, that is the point. That is the point of building the drawer. One of the reasons to build the drawer is to help you to easily link it to the drawer so that your brain has something to do. So the brain is focusing on something, right? And the new information, new understanding, I'm sure there's a lot, right? And now let's read this again quickly. Let's see after this step 1 until step 7, we still have one more step to go. If you can appreciate this even more, let's read it. And let me know when you're done.
Okay, I finished rereading it one.
So I think you feel that the understanding of these keynotes now is much more compared to 2 hours ago when we just started reading it. Am I right?
Yeah.
Yes. I can see the yeah is more strong now. Okay. Now, the last step. The last step is, what do we call that? Create a story. Okay. Don't worry about creating the story. I've already created it for you. And don't laugh on my drawing. That is not the point. We're not testing my drawing. We are creating a story. Let me see, what should I pull out? Yeah, the keynotes. Where's the keynotes? All right, let me just zoom it in. Excellent. Okay, by now we have built 3 drawers, fill them with information, with understanding, practicing linking those information and understanding to each drawer and each sub-drawer. Next step is to translate all this text into story. And why is this important? Because our brain remembers images and emotion far better than plain text or plain words. Story that having emotions, whether it's something that is funny or whether it's something that's sad, it will make your memory stronger. It will make the retention faster and stronger. Right? That is proven in the memory game that we played before. So that is how our brain works. So let's create a story for each drawer. And you can also definitely build your own version. But I'll give you mine as an example so that you can follow it easy. Right? So let's start with drawer number 1. And cross-check with the keynotes, if you realize the keynote is very important in almost each and every, the keynote is right next to us, right? So let's start with the black body, right? How do I explain this story? There's imagine a black body heating up until it glows like a sun. The hotter it gets, the higher frequency and the shorter wavelength. Hotter it gets, temperature up, higher frequency, lambda is wavelength, shorter wavelength. Now, but here's the twist. Even though the sun is so powerful, it doesn't destroy the grass beneath it. This represents the ultraviolet catastrophe. Right? Ultraviolet sunlight is ultraviolet. And the grass beneath it, I intentionally draw it like a wave of frequency, like the sine and cosine. The frequency looks something like this. And that is to tell us this part, right? It was predicted the higher unlimited energy at higher frequency, but it doesn't. So this frequency doesn't, right? Next is Aquan. Aquan is a quite popular surname for a Malaysian Chinese, right? So one of my friends called Aquan, so I'll name him Aquan. You can name whatever name that you think is more relevant to yourself. But for this case, let's stick it to Aquan. Aquan, which is representing the quantum energy, he is now in KL, Kuala Lumpur, right? And then instantly he travels from KL to JB, Johor Bahru, not continuously, but I mean not going from KL to Seremban to Malacca, then to Johor Bahru, but it went from KL. The next second it appears in Johor Bahru. This is showing the discrete energy, right? Quantum energy, discrete energy. It's not continuous. Okay. And Aquan in KL, he waved goodbye. He waved goodbye to the Aquan in JB. And then Aquan, the next second, the same Aquan appeared in JB, and he holds a ball representing the particles. Right? So that is to explain the wave-particle duality. Right? Wave-particle duality. So that is drawer number 1. It's a story of glowing sun and the grass and Aquan, which is quantum energy, their quantum journey from KL to JB. So let's close drawer number 1 and let's open drawer number 2 and see the story. Story number 1, this is the same story, the torchlight story, but I'll just explain it again to make sure that it is all complete. Torchlight shines on the metal. Suddenly the metal eyes pop out, and because the torchlight beam the light to make the eyes pop out, and that pop out light is photoelectron. This is the one. All right. I hope this story, this drawing illustrates by itself. My drawing is not very good. You see, you have a torchlight over here, then you have a metal, then this eye was supposed to be here, and it pop out. Then the next one is the let's name it whichever name, easy. Okay, let's name it easy. Easy at a high jump competition, and she must jump above the bar, and the height of this bar is F naught. That's a threshold, the minimum threshold, which is associated with the threshold frequency, right? So an easy jump and clear this part, this threshold or this height, she has a high motion. That means high kinetic energy, and obviously higher frequency or higher height compared to this threshold. Then only you are able to jump to clear this hurdle. When you jump over, you wanted to eat noodles. You want to eat instant noodle, and that instant noodle is related to the instant emission. Instant emission, right? So before that, let's rewind a little bit. The threshold frequency And also the higher frequency, a higher kinetic energy. Okay, so we have a last one, intensity. And the instant noodle is not spicy. So intensity related to spicy. It's not spicy. So no, the intensity doesn't affect the energy, right? So that's drawer number 2, the story of torchlight, popping up eyes, easy attending the high jumping competition, and noodles, instant noodles. Right, let's close chapter drawer 2 and let's open drawer 3. Oh, drawer 3 is imagine a photon bullet. A photon bullet fired from a gun. It strikes a metal, and that metal is being pushed from position 1 to position 2. And when this is being pushed, two things created. The kinetic energy, because there's a motion now, and there's a work done. The push means there's a work done. When you push something, that means there's a work done. So that reflects the photon energy plus the work function. Work done, work function, plus maximum kinetic energy. Right, maximum kinetic energy. So that's it. So drawer 3, you have the photon as the bullet hitting a metal and doing the work done and creating a kinetic energy. So let's recap. Drawer 1, sun, grass, aquan wave, and then he hold the particle, the ball, and the journey from KL to JB. Drawer 2, torchlight, popping up eyes, easy jumping, and easy eating non-spicy instant noodle. Drawer 3, photon bullet, metal, Einstein formula, the work function, the kinetic energy. That's how you turn physics concept into memorable stories. Although it is illogical story, but it's fine. As long as there is emotion in it, I'm trying to stir emotions. The image might feel funny sometimes, but that's good. As long as your brain remembers unusual story, and is far better than remembering this text, right? So why is this important now? I think you already know why is it important. I'll give you one more reason why it is important. Now, I think by just looking at this picture, you already have a near to 80-90% of understanding of what we have gone through for the past 2 hours. Imagine if you go to an exam hall now. Obviously, you will not be able to bring this note in. Obviously, you cannot bring your books in. And even if you can bring in these notes, or no, I'm saying, even if you can write down these notes in your exam, but the chance of you remember each and every note is far lesser than remembering the story. And imagine if you draw out this entire picture in less than 1 minute. What does it mean? It means that effectively you have already bring the entire book into the exam hall for this chapter. And I'm sure you're not taking exam for 1 chapter. You're taking exam for 10 chapters, for example. So draw this picture and in 10 pages. When you're in the exam hall, it means that you already bring the entire book inside the exam hall. I'm sure you can draw during the exam, right? You can spend, let's say, 30 seconds on each picture to draw these things. And for 10 pages, it's only 3 minutes. Right? It's only 5 minutes. Then the remaining of the time, you can use this picture and to start to answer all your exam questions at ease. Because you already effectively bring the entire book into the exam hall. And even better, books you still need to flip because book is heavy and it's thick. You still need time to flip. This one you don't need to flip. If I tell you where is the radiation, can you explain the black body radiation by just looking into this picture? Do you think that you can explain? Easy.
Yeah.
Hello. Yes. Do you think that you can explain wave particles duality by just looking into this picture, this Aquan KLJB picture?
Yeah.
Do you think that you can explain the characteristic? You remember the characteristic when we first read it, we do not understand what is it. But now, do you think that you can explain with just this picture, the 4 cartoon characteristics, which is this one?
Not all of them.
Right. There are 4. Higher frequency,
Yeah.
higher kinetic energy. So easy jump, higher kinetic energy, higher frequency. Easy need to jump above the threshold, which is the threshold frequency. And easy after jumping, she wants to eat instant noodle, instantaneous emission. And the instant noodle is not spicy. Intensity does not depend on the kinetic energy, does not affect the kinetic energy, right? Then with this story, do you think that you can explain photoelectric effect? With this story, do you think that you can explain the Einstein photoelectric theory? You can, right?
Yeah.
Right. So now, from the scale of 1 to 10, 1 is you do not understand, 10 is you understand. How much do you think you are in now, 1 to 10?
Like 7.
Like 7. Excellent. We can test that later. In step 1, when we just started, you were in 1, or maybe you were in 0.
Yeah.
Right. So only by focusing in 2 hours, you went from 1 to 7. So let's do this very quick test. I will run. Let me just pull this out. I will run a new chat. I will upload the physics, SPM physics chapter 7. Let me just open the file. Right, this is the file. There are 29 pages. Quantum physics chapter 7. Right, so let's go through it quickly at a glance, very quickly, in less than 1 minute. It's talk about the quantum theory of light. Then you have the wave. Gamma is showing the highest frequency. Radio wave showing the lowest frequency. And then you have some radiation. Then you have the quantum physics theory, the ideas. Then you have the scientists, and still scientists, quantum energy, the proton car, quantum energy still, wave particle duality. So you have some experiment. Okay, still experiment. Some exercise, practice. Now it's drawer number 2, photoelectric effect, explaining through an experiment. Right, then characteristic of the photoelectric effect. Remember, this is the story of easy jumping in the competition and then eat instant noodle. Then you have Einstein photoelectric theory, which is drawer number 3. Then you have work function, you have threshold, you have the maximum kinetic energy. Then you have some problems that you need to solve. Okay. Right. BrainDrawer method able to help you to solidify your concept. The concept, that means the understanding of the chapter. To make you exam ready, you need to familiarize with those questions. That is where you need to practice the past year questions and such and such. But with a very strong concept and understanding of the chapter, it's easier for you to answer the questions. Right. In 2 hours, I will not be able to make you exam ready to get a good score in your exam for your structure question, for your essay question. Maybe for the MCQ question, we can still get a very high score. But the structural question like this needs more practice. right? Do you agree?
Yeah.
Yes. So these 2 hours will give you a very strong foundations. And then after the 2 hours, when you start to do more exam questions, it will be super easy to follow, right? But still, you need to put in effort to do it so that you are familiarizing yourself with this type of exam questions. So now these are the textbook for this form 5. Form 5 is year 11, chapter 7. Now what I'm going to do, right? I'm going to upload it into the chat GPT, chapter 7, the one that we saw just now. Then I'm going to ask ChatGPT to randomly pick 10 MCQ questions and to see how much understanding we have, right? Why do I want to do this? To make sure that it is fair, to assess whether if you are reading this chapter by yourself, following this BrainDrawer method, how much understanding you will get from this entire chapter. I intentionally not uploading my keywords or my this document into the ChatGPT because you remember I want to make sure that the notes that I generated is reflecting 100% of the syllabus of the textbook. So rather than uploading the document that is created by me, I upload the original textbook. So you understand the reason? Okay?
Yeah.
Okay, so let's do the assessment. Provide 10 MCQ without answer. Okay, imagine now you are in the exam hall and there are 10 MCQ questions you need to answer. And in the exam hall, you will have this photo because you already trained yourself so much that you are able to draw this photo in less than 1 minute. And you've drawn this photo for you to refer. Okay, so now what I need you to do is also very simple. I need you to read the question and then tell me which drawer and then tell me the answer. Let's do it now.
Okay. So the first one is,
Yeah, I need you to read the question out loud this time.
a black body is defined as a body.
Before reading the answer, which drawer, which subdrawer?
Oh, the light bulb drawer and the black body.
Excellent. Okay, then tell
So
me the answer.
quantum theory of light. A body that absorbs and emits magnetic radiation perfectly.
So B. B is your answer?
Yeah. B.
You sure? Okay. Now, question number 2. Repeat the same drill.
Which of the
Read the
following
question.
best
Tell me.
explains why the classical theory failed to describe black body radiation? So, the quantum theory of light, the light bulb drawer, and then the UV. And it's because it predicted infinite energy at short wavelengths.
B.
Yeah.
Okay.
And then the energy of the photon is given. So it'll be the quantum theory of light and the proton, and that'll be B and C, so D.
Okay.
Which scientist introduced the concept of quantized energy in black body radiation? So that'll be quantum theory of light, and the scientists, so Max Planck, so B.
Okay, move up.
The photoelectric effect occurs when, so that'll be the photoelectric effect drawer and And it's the metal with the eyes which pop out when a light is directed at it. And um, a photon with greater energy than the work function strikes a metal.
A.
So A.
Okay.
And then
6.
which characteristic of the photoelectric effect cannot be explained by classical wave theory? So that'll be the photoelectric effect drawer. And then all of the above. So D.
D. 7.
And then the relationship between work function and threshold frequency is C. It's the third drawer, the Einstein drawer, and then the formula.
Excellent.
According to de Broglie, the wavelength of a moving particle is given by, so that'll be drawer 1 with the scientists. No, yeah, drawer 1 with the scientists and the double-sided coin. I think it's C.
I think it's C. Okay. This is not easy. Okay.
Which of the following is an application of the photoelectric effect? So that'll be the drawer number 2, photoelectric effect. Oh no, drawer number 3, to do with the photoelectric theory, and then all of the above, D.
Okay. Last one.
So in Einstein's photoelectric theory, the maximum kinetic energy of photoelectrons. So drawer 3 with Einstein, and then the formula but rearranged, so it's A.
Is A. Okay. Where is A? Yeah. Okay. Tell me my score. Ta-da! Wow, you got 9 out of 10. Congratulations. And the one that you got wrong is a very difficult question, by the way. So,
Yeah, I didn't remember the formula correctly.
right. So you could have 10 out of 10, but 9 out of 10 is already excellent. Yeah, and you just spend about 2 hours to complete the entire chapters. And the understanding of that chapter is 90%. Is that something that you are impressed by yourself?
Yeah.
Yes, excellent. I think, yep. So this method, it can apply on any chapters, on any subjects. I've tested in physics, I've tested in history, science, even for my subject. I'm learning a second master. There are economics, accounting, finance, even blockchain, Python programming. They are all is applicable. So let's hope that you find it interesting. And congratulations again, 9 out of 10.
Thank you.
Thank you. Bye-bye.
Okay. Thank you. Bye.